Hello, everybody. We're looking at one variable statistics unit 2. So kind of we're backtracking in the textbook, but this is our, I suppose, what is this? Would be our first, second, about our fifth unit in the course. Okay. So what we're going to be talking about today is several different things here. We've got graphs, okay, indices. We got some sampling techniques, biases, and then differences in central tendencies and measures of spread. Okay, this quiz I might end up taking out and just making a full-on test for the entire section at the end, okay? Because really in the end, we're just adding in measures of spread right there. And so we'll just sort of do a test on the whole thing at the end. Here's the textbook questions that you can find some examples, okay? So let's go ahead and start out with some stuff here. So day one, statistics. Statistics is, basically is gathering and organizing and analyzing, and then finally presenting some sort of numerical information, generally speaking, in order to further your knowledge on some sort of question that answers some question that you may have, or different things like that, okay? And so that's, maybe you have a hypothesis and you want to gather some numbers to determine whether or not what you believe to be true is actually true, and different various things along those lines, all right? Whatever the case, there turns out to be a lot of different types of data. So we're going to talk about data types today, okay? So you can collect measurements in some quantifiable amount, right? So we'll talk about, in this unit, we're going to talk about mostly quantifiable, quantitative data, right? But we will be also talking about qualitative data and what's the difference between them. How do we display them? How do we present them? How do we organize the two data types? All right. We're also going to talk about what it means to be a variable, right? We're also going to talk about continuous versus discrete. We already mentioned that a little bit in this course. We'll talk about it again. It is common to graph the variable based on how frequent different values occur, right? These different things. So these graphs are known as frequency diagrams. We'll focus on those today, all right? So there are a lot of vocabulary up in this statement, right? And so let's get all those words clear, plus I'll introduce a few others. So first of all, it's qualitative. Was that one in there? No, I put quantifiable up there, which is, oops. Let me hit that button. I put quantifiable up there, which is, right here. Okay. But, which is basically this one, but what's qualitative mean instead? Well, qualitative just basically means that, it's a variable that it's more of a category. So, a variable that fits, into categories is kind of the idea there. It's categorical, right? So you can't basically place a number on it, but it's more of like a word or something along those lines. Whereas down here, qualitative, this is a variable that has a numerical value. Okay. For example, oops, let me change my keyboard setup. No. There we go. We're set. For example, age. Okay. Up here, more of a category would be, I don't know, something along the lines of color. All right. So there would be something that's variable from one person to the next, would be some sort of characteristic that is a color. And then another thing that's variable from one person to the next would be their age. Okay. Their age. All right. Anyway, so those are sort of two types of bits of data. We also have discrete and continuous. All right. Discrete is more for, sorry. Gosh, guys, this computer's behaving all funny. Discrete is more for qualitative. It's qualitative. I said that wrong. It's quantitative, meaning it has a number, both discrete and continuous. Whereas the difference between discrete and continuous is that the number that you achieve for discrete comes in steps. Okay. And so, for example, you can achieve a 7, an 8, a 9, or a 10, for example. Whereas in continuous, you can achieve a 7, an 8, a 9, or a 10, or any other small fractional number or decimal number that's in between. Okay. So discrete is data that comes in whole numbers generally, okay, or there is jumps. There are jumps, I suppose, between one possible measurement and the next. Okay. And obviously you guys can see that I cannot spell or type. Actually, I go either one. This is supposed to be possible, and that's measurement. And then for some reason my right click isn't working, so I'm just going to go with it. All right. Now, continuous. No. Anyway, continuous is data that comes in. It can be divided up as much as you want. It comes in an infinite range of possibilities, right? And it can be measured to many, many decimal places, basically. Okay, and so, for example, certain examples of discrete would be things like, volume, time. Sorry, I got that messed up. For discrete, things like items are an example of that, right? And so, for example, you would get, I don't know, maybe certain items like people, cars, sales, right? I don't know, days even, right? Either you got I don't know. And then that's another thing. Some values can be discrete or continuous. For example, days, you actually can measure fractional days. But depending on the way that you're interacting with the data, days, for example, it may be considered discrete or continuous based on your interest. Okay. If you're talking about full days of work, then maybe those are discrete, right? Because in the end, oftentimes you don't really have a half day or something like that. Whereas instead, you might be talking about days in terms of in a continuous fashion where you can actually have a half of a day. So things that are continuous would be like time. What else would there be? Volume, lengths, all sorts of lengths, right? And obviously these should be spelled correctly, but there we go. Time. All right. So those are some various data types there. Okay. There's also what's called nominal data. Okay. And by the way, I just want to let you know that this here I'll do this. Well, here I'll do this. I'll do that in a moment. Actually, I'm getting a little ahead of myself. So nominal data are used basically to label variables without any quantitative value, right? And so you would also call this essentially data with a name, right? Okay, and so examples of that would be gender, right? Also, this would be discrete, right? Because you either have one value or another value, and you can't have like fractional gender very much. I guess. I mean, I don't know. Let's not maybe get into that discussion, but let's just make the assumption that we can't have fractional gender. Actually names of people. All right. Again, these are all kind of, generally speaking, you have one single name, right? And you don't have a half of a name. Okay. Anyway, so that would be a nominal type of data, which would be discrete, and it would be qualitative. Okay. So notice that this data basically has three, this type of data, gender, for example, it has three, you can say it has three different things that it is. It's nominal, discrete, and qualitative. Okay. Here we've got ordinal data. All right. This is basically now data with some sort of order to it, some sort of hierarchy. Oftentimes this is used to get people's opinion on things, right? And so it would be, data with a sort of like a high, medium, low type scenario. And so with some kind of order, right? And so how would we do that? Opinions are ordinal data, okay? And basically you can say, well, how is that an ordinal data? You've probably all taken those surveys where it's like, do you, how was your experience with our webpage? Oh, it was, very enjoyable or somewhat enjoyable, or not, it was okay, or it was not very enjoyable, or it was poor. That would be ordinal data. There's some sort of order to it, okay? It has a name, right? So it's qualitative, right? You could kind of, in a way, say it's nominal because you're saying that it's got a name. This is funny data, actually. It's discrete, okay, meaning that it only comes in 5 different types. But you could also in a way, you could say that it's quantitative as well, because you actually can apply numbers to ordinal data, where basically very, I was very enjoyable experience. You could apply a 5 to that, and then somewhat enjoyable, you could apply a 4 to that. And ordinal data is nice, because then what you can do later is you can graph ordinal data. Okay, and so that's kind of what we're doing there. Then we get into interval data. Okay, interval data is essentially continuous data, right? With zero, negative and zero as a possibility. So okay, whereas, and then let's get into its little brother here. Ratio data is continuous data with no zero or negative. And so these are not that interesting. So for example, over here we could have things like temperature, could be a possible data type, okay, with a 0 and a negative. Though remember, though, you can't divide by 0, right? So if it turns out that you have to divide by 0, then a lot of times what folks do is they divide by a number very, very close to 0 if necessary, if you actually have to. But that's a discussion for other things, right? And so, whereas continuous data with no 0 or negative, sorry, that says of negative, it should say or negative, would be something like the height of a person, right? Maybe right? Why is height that way? Well, because you can't have a height of 0 and you can't have a negative height, all right? And so that's kind of the idea there. Now, I just want to, let's see, focus on some of these things. So qualitative data, right, is oftentimes discrete, right? It could be nominal, it could be ordinal, right? Quantitative data, it could be discrete or continuous generally. It could be with zeros or without, right? And so basically, we're going to take a look at that, those types of things, right? Please ignore the spelling typos. I see that here I've written numbers, right? I was just typing very quickly. That's obviously supposed to be numbers. But numbers, pretty cool word, new one for us. All right, so let's create a bar graph that someone could use to quickly observe the hair colors of the people found in this room, okay? Well, I'm in a room all by myself, and so I'm just going to make up some numbers here. And so let's say I've got some brown hair people, and I've got some blonde hair people in here, and I've got some red-headed people, and I've got some gray, right? And I would go around and I'd say, okay, there's 2 of those. There's maybe 3 of these. There's maybe 5 redheads and I guess 2 gray-haired people, okay? This would be considered the raw data. And now over here, we're going to make a bar graph where we're going to have the organized data, okay? And so what I'm going to do is I'm going to write down blonde, brown, gray, and red. I went ahead and put those in alphabetical order, okay, because it's nice to have some sort of order in there. And for qualitative nominal data, Oftentimes it's measured or placed in some sort of alphabetical order, um, even though it's not an ordinal, right? There's no reason why. Like I haven't done this because maybe red should be assigned the number 4 or anything like that. All right, it just happens to be like this. And so I'm going to make a little bar graph here. On my bar graph, I'll put a 5, a 4, a 3, a 2, and a 1. So here I've got blondes. I've got 3 of those. So I'll make a little bar. I've got brown-haired people. How many of those do I have? 2. Gray-haired people, got 2 of them. And redheads, we got 5 of those. There we go. Bar graph looks pretty exciting. And so this bar graph should have a title. And so this is, hair color in my imaginary room that I made up. And this is now organized data. Okay. And then over here, I should write the number of people. You can write just people. That should be pretty clear. So anybody looking at this can quickly and easily see that there are 3 blondes, 2 browns, 2 grays, and 5 red-haired people in this room. Okay. Let's just quickly discuss what types of data this is. This is discrete. Okay, because it comes in sort of jumps, right? You have brown, you have blonde, you have red or gray, and you don't have much in betweenness, even though these days people's hair colors, all sorts of crazy colors. But, just for the sake of making this example possible, let's make the assumption that you can either have brown or blonde, but nowhere in between. What else is this? This is nominal data because it's got names. It's discrete. It's qualitative. Okay. That's our data. And this would be a bar graph. All right. Now, use the raw data given to the left to create a histogram. Be sure to choose an appropriate scale. Okay. Now I'm doing this. All right. This was supposed to be written up there. I've got a little bit of a crisis here on the, maybe I can pull that. No, I can't pull that around. All right, I'm going to leave that data there. All right, so what I'm going to do now is I'm going to make a histogram, okay? Oh, I got to make a scale here. I'm going to choose an appropriate scale. If I'm making a histogram, basically what I want to do here is I want to say, all right, look, I've got maybe the highest value that I happen to have is, I don't know, here it is, about 5.5. And my lowest value is 1 or so, okay? This data appears to be somewhat continuous. It is discrete, okay, like meaning I have only certain possibilities, but maybe there was a bit of a continuity in here, like this 1.63 does represent something very close to 1.63. So what I'm going to do is I can't make like a histogram and write down 1.1 1.00, I can't make a bar graph and then do 1.01, 1.02, 1.03, and then just tell you, I've got 3 of these and so forth. That would be really, really large, right? So it would be something you could do it, but it wouldn't be like people would be like, why'd you make that graph like that? So weird. So in the end, basically what you want to do is you want to break it into groups. So let's do 1s, 2s, 3s, 4s, and 5s, basically. All right. And now I'm just going to basically grab up some raw data, right? So I've got 1, 1, another, another, and another. So there's 6 ones. A 4, another 4, a 3, a 2, a 2, a 2, a 3, 4, somewhere in the 5s. There's a 5, there's a 2, and then I've got 4 more ones. 1, 2, 3, 4. Excuse me. So this is basically now my histogram, okay? And a histogram is basically a bar graph, just like above, but you use it when the data is continuous. And so as a result, we've got 1, 2, 3, 4, and 5. And since this data is continuous, well, how many ones do I have? I've got 10, right? Then I've got 5. And so here I've got 10 ones. Okay. I've got 4 2s. All right. I've got 2 3s. I've got 3 4s. And I've got 2 5s. Right. Let me go ahead and do a 4, a 3, a 2, and a 1. Right. And there we've got, I don't even know what this data is. Let's say that this data is, wow, who knows what this data is. We would say random sample data. Let's just call it that. And this is, you could sometimes call this the frequency. It's a Q, frequency, meaning this is how frequent the number 1 shows up. So it shows up 10 times. How frequent the number 2 shows up. How frequent the number 3, the number 4, and the number 5. And this data is continuous. All right? The reason why we know it's continuous is because these bars that I've made they touch. Up here, the data is discrete. Okay? Because there's a space between the 2 bars. Down here, the data is continuous because the bars touch each other. So that's one way of folks sort of delineating the difference between continuous and discrete data using a bar graph, okay? Up here, it's called a bar graph. Down here, you would call it a histogram, okay? That's it. No big deal there. So now use the raw data. This is the same data again. I'm going to make a frequency polygon. My copy paste got all messed up here. So now I'm going to make a frequency polygon. Okay. And a frequency polygon, this is just another way of making the same data. So let's just say we've got 1s, there's 10 of them, 2s, how many 2s were there? There were 4 2s, 2, 3, and 2. So 4, 2, 3, and 2. So 1, 2, 3, 4, and 5. So remember my data here. So I'm going to do 1, 2, 3, 4, and 5. Now, a frequency polygon, basically, what you do is you put a little dot at the value where the number is, the frequency at the number 1. The number 2 obviously shows up at 4 here, so I put another little dot. The number 3 shows up at 4, 3, shows up at 2, okay? The number 4 shows up at 3, and number 5 at 2. And a frequency polygon actually is basically a line graph where you connect the lines. All right. And this is just the random sample data. Call this over here frequency. Okay. And there we have it. This is a frequency polygon. All right. A relative frequency polygon, we'll do that one here. Okay. It's going to be the same idea, right? 1, 2, 3, 4, 5. But instead of having just the frequency here, we're going to put the percentage of the total, right? The percentage of the total, right? So let's figure out how much we've got. We've got 10, 14, 15, 16, 17, 18, 19, 20, 21 bits of information. Okay. Oh, that's a bummer. 21. And so basically what I'm going to do is I'm going to put 50% right here. And if we do that, 10 out of 21 is around, what is it? Around 40 something, 46 more or less maybe percent. Oops. 46%. Let me just double check that. Probably 10 divided by 21, 47.5 actually. So it was pretty much 48 almost. So around 48%. Okay. 2 out of 21. No, we need 4 out of 21. 4 out of 21 would be 4 divided by 21, which would be about 19%. 2 out of 21 would be half of that, right? So let me see what it rounds to. 9.5, because it was pretty much 19 on the nose. What else do we have here? 3 out of 21, right? 3 divided by 21 is around 14%. All right. So what am I doing here? I'm essentially just sort of getting my 10, 4, 2, 3, and 2, 10, 4, 2, 3, and 2, figuring out what percentage that is of the entire group of 21. All right. And so now, basically, I draw pretty much the exact same thing as above, a dot here, a dot here, a dot, dot there, maybe there, and there. But instead of over on this side putting, instead of putting numbers or the frequency, I'm actually going to put the percentage over here, okay? So what I'll do is I'll make this a little bit bigger. So this is going to be 50%, and it's actually 48%. So notice my little dot is just a little bit below 48 there. You kind of see that? And then this number should be at 4, so it's around 19%. So 25% would be here. And so you could kind of see that that's around 20%, 19%. And then you go half of that, you get around 10% right in this area, 10%. So this guy actually should be a little lower because he's around 9.5%. So is this guy. All right. But if you look closely, it's the same graph as above, but the only difference is that you put percentages instead of numbers, okay? So what's the difference? This one is called a relative frequency diagram or polygon, where this one up here is just a frequency polygon, okay? So hopefully that's pretty clear. This one is a frequency polygon. This one is a relative frequency polygon, okay? We got one last question here. Cumulative frequency polygon. All right. And I just wanted to do this one. Cumulative one means what you're doing is you're actually gonna sort of stack. So as you got your ones, your twos, your threes, your fours, and your fives in this group, right? How many ones did I have? Let me go. There were 10 of them. So I'm going to go ahead and put. Sorry, I'm moving the thing around so much. Let me put a 20 here. So there were actually 10 ones. All right. And how many twos were there? I keep forgetting. There were 4 twos. We're looking here. There were 4 twos. All right. So let me go into here. So rather than putting a 4 down here, because it's cumulative, basically what you're meaning is you accumulate so your new number goes up here. So this one actually should be at 14. And because you know it's a cumulative frequency polygon, what this means is you have to know what's going on here. It's not that the number 2 has 14 occurrences. The number 2 has 4 occurrences, which are 4 more than the previous one. Okay. And then the number 3 had 2. And so you would go up to not only 14, but you would go up to 16. Okay. So this was at 14. This is like 16 right here. So this guy would go to here, right? And then the number 4 had 3 so we'd go up a little bit more. And the number 5 would finally end at 21. Okay. 21, which would be this value right there. All right. So the cumulative one, basically what you end up doing is you keep producing, as you keep stacking onto the previous value. Okay. Why you would want to make a cumulative frequency diagram is if the growth is sort of important, right? You know what I mean? If the focus of the data is you want to draw people's attention towards, not necessarily how much each individual thing has, but how much something is compared to the previous value. Okay. So that would be a cumulative frequency diagram. Tomorrow we'll talk about pie charts. And so I'll put that on there for tomorrow.